In this video, we will show the functionalities of Abstat, an RDF profiling tool. Abstat takes as input an RDF dataset and optionally an ontology and produces a profile. Abstat profile consists of an RDF summary and statistics about the data. The summary of a dataset describes its content by listing most specific schema-level patterns that occur in the data. In addition, semantic profiles provide several statistics. The menu on the left side can be used to manage and explore semantic profiles. The overview page gives an overview of the uploaded datasets, ontologies, and computed profiles. Summarize page gives a configuration interface for custom summarization, including datasets and ontologies uploading. Consolidate allows to persist and index the computed profiles into the search engine. Browse is the GUI for constraint-based pattern exploration. Search is the GUI for full-text searching, where the user can input a keyword and patterns, predicates, or types that match the keyword will be returned. Manage allows to remove datasets, ontologies, and profiles, while API lists the available APIs for meshing-friendly profile exploration. We will start with an example of exploring the profile of a dataset that is already processed in Abstat. We will explore the profile of DBpedia, a sample of the whole DBpedia with more than 49.5 million triples. The first thing that the user has to do is to go to the Browse page and select from the list the dataset that he wants to explore. We can now explore the profile of such dataset. Let's take a pattern example: person, birthplace, settlement. This pattern tells us that in the dataset there are entities of type person linked to other entities of type settlement using the predicate birthplace. For each pattern, several statistics are then returned. First, it is shown the frequency of the pattern, which shows how many times does this pattern occur in the dataset. Instances shows how many instances have this pattern, including those for which the types person and settlement and the predicate birthplace can be inferred. Maximum, average, and minimum subject-object cardinality is the maximal, average, and minimal number of distinct entities of type person linked to a single entity of type settlement through the predicate birthplace. Maximum, average, and minimum subject-objects is the maximal, average, and minimal number of distinct entities of type settlement linked to a single entity of type person through the predicate birthplace. The latest feature that we have integrated in Abstat is the identification and the validation of possible errors in the data. Such information is given under the severity. For the identification and validation of possible errors, we use Shackle, a W3C recommendation language used to write and validate constraints about the data. Every pattern is translated into a Shackle profile with constraints about the maximum and minimum cardinality. We identify three severity levels: errors, when the cardinality of a given predicate does not respect the semantics of the predicate defined into the ontology, and here we refer to functional properties that should have the value for maximum and minimum cardinality equal to 1. For all the other predicates, we apply a heuristic rule, the violation of which is shown with a sign warning in Abstat. A warning is issued for all patterns for which the maximum cardinality, either subject-wise or object-wise, is greater than twice the average, and valid when such heuristic is respected. We are aware that such heuristic is very shallow, but this is the first step towards the identification of possible errors. We are working on applying different machine learning algorithms to learn from the data the maximum value for the cardinality. So, if we consider the following pattern: person, birth date, date, we have from the data that the minimum cardinality object-wise is equal to 1, the average is 1, while the maximum is 4. But birth date is a functional predicate in DBpedia ontology, thus such predicate should take only one value. In order to investigate the entities that violate such constraint, we can click Details. At the top of the page, we see the pattern which we are now inspecting. The page for the validation has three other windows. First, the cardinality subject-wise, the number of distinct subjects linked to the same object. The second window is used to inspect the cardinality object-wise, the number of distinct objects linked to the subject. And the third window appears when the user selects to inspect possible cardinality violation. While it is correct the cardinality subject-wise, meaning that it is correct if 2004 different persons have the same birth date, which in this case is 1st of January 2000, it is not correct the object-wise cardinality. There are entities of type person that have 4 different values for the predicate birth date. For example, the entity of musicians of the RMS Titanic has 4 dates of birth, and we can see that all the values are different. And so on, we can inspect all the other triples that have more than one value for the predicate birth date. Another interesting example is the pattern company, number of employees, non-negative integer. The predicate number of employees is not a functional predicate, so in this case the heuristic is applied. If the maximum cardinality is greater than twice the average, then Abstat gives a warning. In this case, the average cardinality object-wise is equal to 1, while the maximum cardinality is equal to 6, so it is greater than twice the average. If we click Details, then we can inspect which triples have issued this warning. Indeed, as we can see, the company Freeport McMoran has 6 distinct values for the predicate number of employees. And here we have all the values for such predicate for this entity. The user can in this way inspect all the triples that have issued such warning.